This video is about a seemingly simple problem that actually is quite tricky at its core. Alright, what we're going to do is we've been given a parabola here and we're going to state a possible equation for this parabola. Alright, so because we've been given the x-intercepts here, what we're going to say is that the equation could take the form a, x take, let's say d, x take e. Alright, so this equation here is good when we've got x-intercepts given to us. Now, in the questions that we're going to do, we're going to assume that the dilation factor, a, is always equal to 1. Now, it's not always equal to 1, but we're just going to assume it for the questions that we're doing. So that leaves us with this form here, x take d, x take e. Alright, now what we're going to do is we note that we've got an x-intercept of 2 and 4. So I'm going to put those into this form of the equation, x take 2, x take 4. Now we're going to check out whether this indeed would or could possibly be the equation for this parabola. So we're going to say 0 equals x take 2, x take 4. So I'm finding the x-intercepts which occur when y is 0. So applying the null factor law, x is 2, x is 4. That checks out. Good. Alright, so most of you have or should have no problem with that one. Let's go to this situation here. Now the parabola looks exactly the same, except this time the x-intercepts aren't listed as numbers, rather as b and a. That's fine. Let's list them. b, 0 and a, 0 are the two x-intercepts. Let's write our form that we've been using, and again assuming a dilation of 1, x take d, x take e. Right, so as with last time, pop that in there, x take b, x take a. Right, so x-intercepts occur when y is 0. Let's do that. Let's apply the null factor law, x equals b, x equals a. That checks out totally. Alright, so on to something a little bit harder here. Okay, now what we've got here is a parabola that goes or has an x-intercept on the positive side of x and the negative side of x. So let's write up our form, again assuming that the dilation is 1. X take d, x take e. Alright, so one of our x-intercepts is 3, negative 3 rather, other one is 2, so let's slot them in. Alright, that is y equals x plus 3, x take 2. And again, let's just check this out. X-intercepts occur when y is 0. Null factor law. Okay, that checks out perfectly. Alright, so here's the tricky problem, or the first of the really tricky ones. Alright, so what a lot of students think is because this b value here is on the left side of the origin, or in the negative side of x, they think the equation would be x take b, x plus b, x take a. So they think this would be a possible one for that. Now why do they think that? Okay, they think that this is the case because if I solve via the null factor law, 0 equals x plus b, x take a, x could be negative b and x could be a, or x is negative b and x is a. Now, why isn't this the case? Well, this is saying that one of the x-intercepts is negative b, and it's not, it's b. Okay, so we don't care whether it's negative or positive, we're just saying that the x-intercept is b in this case. Okay, this says the x-intercept is negative b, so it's wrong. Now the a value, well, that's right, x is a. So, we're going to avoid using this approach here, and we're going to look at it from the same way, or look at it using the same method that we've been doing for the other questions. So we're assuming dilation factor of 1, x take d, x take e. We're going to slot in our intercepts, which are b0 and a0. So that goes in there, and that goes in there. Y equals x take b, x take a. Now, does this check out? Well, we know it will, but I want to prove a point. X-intercept occurs when y is 0, x equals b, x equals a via the null factor law. That checks out. Alright, finally here we've got an inverted parabola. Let's note the intercepts. And what we're going to do is use the equation that we've been using, or the form of the equation that's best suited to intercepts, which is x take d, x take e. Now we're also going to note that because this is an inverted parabola, there's a negative sign here, or a negative sign, -1 multiplied by either of the binomial factors, or binomial products. Okay, so let's put b and a into there. Y equals x take b, x take a. Negative sign. Alright, so what I want to do now is check out how this looks in GeoGebra. So what we'll do is we'll go y equals negative x take b, x take a. Alright, now what GeoGebra does is it says, alright, we want to create some sliders here, and I'm going to give b a negative value and a positive value. So let's go b, drag it over to -2 or something, and about that, and a 2, whatever. Alright, and what we find is with b being a negative value and a being a positive value, that we certainly get the case of the parabolas looking similar. Right? It's not the same parabola, it's not the same a and b values, but it gives us an idea that, you know, we have got a correct form of the equation. Alright, so now on to the question that was a tricky one in class today. Okay, so we've got this possible equation, or these possible equations for this polynomial function. Right, so it's a pretty good idea with a multi-choice to just scan your eye over it and work out which ones can't be correct. Now, because this is an inverted parabola, anything with a positive squared term it's just going to be out. So this one's out. That's an upright parabola. This one is also an upright parabola. This one will invert because of the negative sign. This one will invert because of this binomial product. Now, why is that the case? I've got y equals x plus b, and I'm going to pull out -1 as a common factor, and I get x take a. Alright, and so that negative then can be put here at the front, okay, because the multiplicative nature of multiplication, the order doesn't matter. So that is certainly an inverted parabola, and this one here is an upright parabola, so it's out. Right, and so we'll note that we've got either a 50-50 chance now, but we're not going to leave this to chance, we're going to know what we're doing. So our form will be negative x take d, x take e. Slot in our intercepts, y equals negative x take b, x take a, and we've got a winner. It's this one here, C. So, tricky problem there, no doubt. Alright, this one here, we've got a cubic here, and so this is, you know, we're not going to cover cubics for a while longer, but I thought I'd show you, you know, what the stakes are. So what we'll learn later on is that a positive cubic graph looks like this, negative cubic graph looks like this. So this one here I know is a negative cubic graph. Now when I get this situation here with a cubic where I kind of bounce or touch the x-axis and come back up again, so we come into the x-axis, touch once and come back off it, okay, what will happen here is this linear factor of the cubic here will be squared. Okay, this one won't be. So let's write up what this will look like. So it's going to be y equals negative, and we're going to get x take b all squared, x take a. So all we're doing is we're putting the b value in there, the a value in there. Okay, so let's see if we've got a winner yet. Okay, so we're looking for anything with x take b squared. So this is a distinct possibility, but because there's no negative sign here, then this one's out. This, no way. X take a is being squared, which means it would bounce there, okay, and it doesn't. Okay, this is a negative cubic, but it's plus b, so it's also out. X take b, and what's this we've got here? We've got the a take x. Right, now again, I think this is the answer here. Okay, now this one can't be the answer because this is x plus b, so that's out. So by default, this would be the answer. Now again, why doesn't it match mine? Well, let's just look at the answer. X take b all squared, negative 1, x take a comes out, y equals negative x take b, x take a, which now does perfectly match what we've got. So our answer is D. Okay, that question came up in my class a few years ago, and I obviously didn't teach it well because 0 students in my class actually got this right. It's also not really a Year 11 problem. It doesn't, or it's not part of the Year 11 course, and we don't see it in any textbooks. But you know, look, why not have a look at it in Year 11 and get ready for Year 12?